are a couple example problems. These are questions 1 and 4 from your practice problems homework. And I just want to quickly go over how to set up the proportions so that way you are on the right track no matter what. Okay? So the first kind of problem that I want to go over is if you're given how many grams of solute and how many milliliters or centimeters cubed, remember they're the same thing, of solvent in the solution that was mixed or measured. So this would be like number 4 on your practice problems, okay? So the way we always set up our proportion is we always put the real world solution, so the one that you actually mixed or measured, on the left, and then we always put the concentration or the solubility, which means concentration of a saturated solution, on the right. Okay? So on the right goes your concentration or solubility, which is always how many grams are there in 100 centimeters cubed of solvent. So that number always goes on the right-hand side. How many grams in 100 centimeters cubed of solvent? On the left-hand side goes whatever numbers you actually mixed up. So that's going to be your grams of solute divided by your centimeters cubed of solvent. Let's do an example. Question number 4 reads, if it takes exactly 15.0 grams of solute to saturate 67.0 centimeters cubed of water, what is the solubility of this solute in water? So it gives me grams of solute. It says it's 15.0 grams. And it gives me centimeters cubed of solvent. It says 67.0 centimeters cubed. So I'm given those two numbers. Because that's the real world solution that's really mixed, then I put that on the left. So I would set up my proportion to be 15.0 grams over 67.0 centimeters cubed. And then I'm looking for how many grams would go in 100 centimeters cubed. And then you can solve this proportion for x however makes sense for you, whether it's scaling up and scaling down, or cross products, or solving for x. So that's one type of problem that you're commonly going to get. Another type of problem that you're commonly going to get goes the other way. You're given the concentration or the solubility, and you need to figure out an actual solution. An example of this is problem 1. So just like before, we always put the concentration or the solubility on the right, and we put the real world solution, whatever's mixed or measured, on the left. Okay? So this is going to be how many grams are there in 100 centimeters cubed of solvent, and this is going to be how many grams of solute actually went into a certain number of centimeters cubed of solvent. Okay, so what does question number 1 give us? It says if a solution has a concentration of 15.0 grams per 100 centimeters cubed, how many grams of solute are dissolved into 100 centimeters cubed of the solvent? So it gives you the concentration, which is 15.0, and it also gives you the centimeters cubed of the solvent, which is 110. So when I set up my proportion, my concentration, 15.0 grams in 100 centimeters cubed, goes here on the right. And then 110 centimeters cubed goes here on the left, and I'm looking for grams of solute, because this is the unknown. Now that I have this proportion set up, I solve for x however I want to, whether it's scaling up or scaling down, or solving for x, or doing cross products. All right, give these problems a try, and we'll go over them and see how you do.